Hello everyone, this is Sangeeta, Assistant Professor ECE Department, SNS College of Engineering. So today we are going to discuss about the basics of BJT. So let us have a small recap about the previous portion. In the previous class we discussed about the basics of analog and digital electronics. So analog electronics represents the continuous signal with respect to time. Example for analog signals are temperature, pressure, and digital electronics deals with the discrete values, that is zeros and ones. And according to the analog signal, the components used are resistor, capacitor, inductor, diodes and transistor. So resistor, capacitor and inductors are called passive components. They do not require any external power supply, and active components are diodes and transistors. So let us discuss about the transistor. So transistors are active devices. It requires power supply for their external power supply for their use. So the transistor, that is bipolar junction transistor. So in the name itself we can say bipolar, by two polar junctions, that is. The types of transistors are NPN and PNP. So it consists two junctions. Okay. So for NPN, the two junctions are NP and PN. Similarly for PNP, the two junctions are PN and NP, and it consists three terminals: emitter, base and collector. Here I have mentioned the symbol base B, and in emitter there is the arrow mark and the collector. So that is the emitter. In NPNP transistor, the emitter emits the holes, because in P junction, in P junction, the majority carriers are holes, and in N region the majority carriers are electrons. So in PNP the emitter emits the holes, and base is a narrow base. It controls the number of holes emitted in PNP transistor, and collector collects the holes emitted by the emitter. Similarly, in PNP transistor, the emitter emits the electrons. Base is a narrow junction, narrow region. It controls the flow of electrons, and collector, we can collect the electrons emitted by the emitter. So IE, that is emitter current, is equal to base current and collector current. So in terms of voltage, VEB plus, that is voltage between emitter and base, and the summation of VBC, the voltage between base and collector, and VCE, the voltage between collector and emitter, is 0. So bipolar junction transistor regions, that is configurations. So there are three configurations: common emitter, common base and common collector. The first one is common base, that is both the input and output share the base as common. So in this configuration, the base is connected to ground. So the input region are P and N, and the output region are N and P. That is, the input is applied between emitter and base. The output is collected between base and collector. So the input is applied VIN, VB, and Vout collected from B and C. So the input current is IB, the output current is IB. And in both common emitter, both the input and output share the emitter junction. So the emitter junction is grounded. So the input is applied between emitter and base. The output is collected between emitter and collector. So the input is VEB and the output is VEC. So the input current is IB and the output current is IC. So it is the widely used configuration. Common emitter configuration is the widely used configuration in many application, but the common base collector is rarely used. The last configuration is common collector. As said earlier, the collector is the common for input and output. So the input is applied to base and collector. The output is collected from collector and emitter. So the input voltage is VCB, that is voltage between collector and base. The output voltage is VEC, that is emitter and the voltage between emitter and collector. The input current is IB and the output current is IE. So it is also a widely used configuration. So there are some biasing modes, that is active mode, saturation mode, cutoff mode and inverted mode. So the active mode, that is both the junctions or that is active mode. In active mode, input junction is forward biased and output junction is reverse biased, and it is useful for amplifiers. Okay, most of the our work will be used this mode. So and saturation mode, both the junctions are forward biased, and cutoff mode, both the junctions are reverse biased. So saturation in saturation region, in saturation mode, the transistor is used as a switch. In active region, the transistor can be used as an amplifier, and the cutoff mode, the transistor can be used as a switch. Inverted mode, rarely it is used. So these are the three types of biasing mode. So biasing polarity EB junction, that is active EB junction and CB junction. Okay, in active mode, both the EB and CB junctions are forward biased, and for saturation mode, EB junction is forward biased and CB junction forward biased. Rather, both the junctions are forward biased. Cutoff mode, both the junctions EB and CB modes are that is regions, junctions are reverse biased. So this is the equilibrium condition. By reverse biasing both junctions, the barriers to diffusion current flow are increased, so resulting in only a small leakage current flowing. So this looks like an open switch. So this is the equilibrium condition. So hope this video will help you to understand what is BJT, what are the basics of and BJT. So this is the assessment time. So what are the two types of BJT? Next question is, what are the three terminals, and what is meant by saturation region? How the junctions are connected in saturation region? So thank you. You can send your answers in the later.